Hey Algebra 1, here are the notes for 10.3, day 1, solving by completing the square. So to start out, what would we do in order to solve that equation? Well, we know that the only way to undo a variable squared is to take the square root of that. By taking the square root, it gives us just the variable. But in order to keep it balanced, whatever we do to one side, we have to do to the other. And in doing that, we take the square root of 25, which we know is 5, because 5 times 5 is 25. However, what some of you may not realize if you haven't seen square roots before, is that when we take the square root of any number, we actually get the positive version of that number as well as the negative version of that number. So the little symbol that I've put here is called a plus or minus sign. And what that tells me is that positive 5 times positive 5 is equal to 25. However, why did I use the negative 5 as well? Well, because negative 5 times negative 5 also gives me a positive 25. So whenever I take the square root, every single time, square root will result in a positive and negative version of my answer. And that's something that we have to remember. That is one of the most important things you're going to learn on this section. So this concept can actually help us solve really challenging equations like this. But we have to use our factoring skills. And that's last chapter. We should be really good at that. By now we've done a lot of practice. So let's solve this section. The first thing I'm going to notice is, hey, that 9 is a really nice number. And why is it a nice number? Well, because if I notice, that is a perfect square root. That means that when I take the square root of 9, I'm going to get a 3. It would be really nice if I had something that was a something squared on that side. Well, the cool thing is if you notice that when we factor this side into our two sets of parentheses, notice there's no number in front, so I can just break it down immediately into these two sets. Now, let's see, what multiplies to a positive 1 but adds to a negative 2? Well, only 1 and 1 multiply to 1, and to get a negative 2 in the middle there, I have to make them both negative. Notice, negative 1 times negative 1 is a positive 1, negative 1 plus negative 1 is a negative 2. So I have factored the left-hand side. Now, why was that useful? Why did I want to do that? Well, if you think back to our factoring days of chapter 9, I can rewrite the left side as x minus 1 squared instead of x minus 1 times x minus 1. Well, why does that now help us? Well, if we look back at our original, we notice as long as there is something squared, we can take the square root of it. So, in this case, if we take the square root of this side, the square and the square root cancel out, and all I'm left with is x minus 1 on this side. However, just like I did in the first problem, whatever I do to one side, I must do to the other. So, I take the square root of 9. But what was my big reminder? All your square roots will result in a positive of the answer as well as a negative of the answer. So when I take the square root of 9, I'm going to say plus or minus 3. Because that, excuse me, is both the positive and the negative version of that answer. Now, how do we solve it from here? Well, that's a little different. If we have the positive as one option and the negative as the other, we now need to split this into two separate solutions. We need to say that x minus 1 could equal the positive version of 3, or x minus 1 could equal the negative version of 3. So by taking the square root, you notice it has a exponent of 2. That should mean that we're going to get two answers, and this step is how we do that. So now let's solve. Move that 1 over by adding. We get x equals 4. We move the 1 over here, and we get x equals negative 2. Just like that. This method of solving by by having squares on both sides and taking the square root is called completing the square. And you'll see in tomorrow's video why we call it completing the square. However, today I just want you to get really comfortable with this idea of how to actually make this method work. So let's do another example here. This says x squared minus 4x plus 4 equals 5. Now, this right side isn't a nice square, but because I know that I'm using completing the square in 10.3, I'm still just going to try to start by factoring this side. I notice there's no number in front of my x squared, so I can immediately break it down. Tell me what multiplies to positive 4, but adds to negative 4. After a little bit of thinking, I notice that 2 and 2 multiply to 4, and to get the middle number to be negative, both of these have to be negative. And you can check yourself on that if you want. And of course, it still equals 5. Now, eventually you'll get to the point where you can skip this step of rewriting it as a square, but until you're really good at it, I would like you to show this step as well. All right, from here, we take the square root of both sides, and by doing that, we get x minus 2 equals 5. Now, I left a space there. Remember, what must always go in front when we have taken the square root? Plus or minus. Now, why did I write a 5? Well, because there's no nice square root of 5. So when there's no nice square root, we just write the square root of 5. And even though we took the square root, it's still plus or minus. All right, now let's solve it by breaking it down. We're going to have x minus 2 equals positive root 5. But we're also going to have x minus 2 equals negative root 5. Now you're asking, how do we solve from here? This last problem had nice numbers to work with, and this one doesn't. Don't freak out over the square root. You're still going to solve it the same way you would as if that was a variable. We would still just move things away from the x. In order to do that on this side, I'm going to add 2 and balance it out by adding 2 on that side. And I'm left with the answer 2 plus root 5. Same thing with this one. I'm going to add that 2 over. Be careful, there is a negative out in front. So I'm going to say 2 minus root 5. Just like that. And then these are my 2 final answers. All right, let's flip it over and see what else we have. I would like you to pause the video here. I would like you to try these 3 on your own, and once you've done that, come on back, see if you got them right. All right, hopefully you had a moment to try those on your own. Let's work through these together now. It's going to be a nice problem, I see, because I have a nice square root on the right side, but even if I don't, I can still work with it. Let's just start by breaking this side down. No number out in front, no need for the x puzzle. I've got an x, I've got an x. What multiplies to 4 and adds to 4? Conveniently enough, it's 2, and because both of them are positive, and it still equals 9. Now, this is the last one I'm going to show this step for, but remember, this is what I'm doing every time. I'm saying if that side's squared, I can take the square root of both sides. Square root the left side, square root the right side, and I'm left with x plus 2 equals, the square root of 9 is 3. That one's a nice one, so we don't have a square root left. But remember, I always get the positive version and the negative version. Let's remind ourselves of why that is. A positive 3 times a positive 3 equals 9, but a negative 3 times a negative 3 also equals 9, so we have to include the negative version as well. All right, let's jump down to our 2 solutions. We have x plus 2 equals positive 3, and we have x plus 2 equals negative 3. Solve those, we get x equals 1 and x equals negative 5. And those are your final answers. Please show all of these steps on your homework, at least for the first few problems, so I know that you've got this down and you're not just winging it. All right, let's see another one. No number in front, no need for the x puzzle. Pop it into the solution here. What multiplies to 9 and adds to a negative 6? Is there anything that adds to a positive 9 but multiplies to a negative 6? Yes, I did make you think that hard about that one. It is just negative 3 and negative 3. Notice it has to be the same on both sides in order for us to put it in this form. If it's not the same in both of these, we cannot use this method. Just a little reminder. All right, we've got r minus 3 equals plus or minus 4. Notice I skipped a step here. I didn't take the square root both sides on my paper, but that is how I got to that step. All right, two solutions. R minus 3 equals positive 4. R minus 3 equals negative 4. R equals positive 7. R equals negative 1. Two answers. All right, and the last one, this one's not going to be as nice because it doesn't have a nice square root on that right side, but that doesn't mean we can't do it. All right, no number out in front. Go directly to the parentheses. M&M, what multiplies to 16 and adds to negative 8? 2 negative 4s will do it. I'm going to skip my usual step of rewriting it this way and go directly to m minus 4 equals, the square root of 2. So I'm not going to skip that step. Not yet, because that'll come in handy tomorrow. So I am going to take the square root here, and I'm not going to show that step just because I don't want to rewrite it. But m minus 4 equals the square root of 2. Notice since it's not a nice one, we just leave it in the root. I still have to bring into account that positive and that negative. All right, last step, two solutions. M minus 4 equals root 2. M minus 4 equals negative root 2. Finish those up, and you get positive 4 plus positive root 2. And m equals positive 4 minus root 2. And you can approximate those. You can actually put those in your calculator if you'd like. However, for the sake of simplicity, I'm just going to leave them in that form. I kind of prefer that form. It looks a little bit nicer to me personally. So, all right, that is your first day on completing the square. Let me know if you have any questions.